In this video we're going to look at terminating and recurring decimals, what they are, and the difference between the two. The first one, a terminating decimal, is fairly easy to describe. If we have the fraction a half, an equivalent decimal for that, we all know, is 0.5. This is a terminating decimal. You'll see that there's no extra digits following on, there's no repetition, it stops at 0.5. Now this can be demonstrated by doing some long division as well. If we say 1 divided by 2, which is what this fraction means, we can add some extra zeros here in order to perform this division. 2 divided by 1 doesn't go, so we write a 0. We carry our 1 on to the next decimal and we put a dot up the top to show that this is now a decimal. 2 goes into 10 5 times. And you'll see there's no remainder. 2 goes into 0 0 times, 2 goes into 0 0 times, and so on forever. And so we can write this terminating decimal as 0.5. Not all numbers though are this easy. If we look at a number like 1/3, this is not a terminating decimal. When we convert this number into a decimal, we're going to end up with a recurring decimal. Let's have a look. So if we say 3 divided by, actually I'm saying 1 divided by 3, and we add some extra zeros because we're going to need them this time, you'll remember that 1.0000 is the same value as 1. If we say 3, how many times does 3 go into 1? It goes 0. We put our decimal place and carry our 1 over. 3 now goes into 10 3 times, and you'll see that this time, because it was 9, we've still got 1 left over. 3 goes into 10 3 times, and once again we've got our 1 left over. 3 goes into 10 3 times, and once again we've got our 1 left over. 3 goes into 10 3 times, once again we've got our 1 left over, and you can see that this pattern is going to go on forever. Each time I put 3 into 10, it's always going to go 3 times, and there's going to be 1 left over. And so I'd have to continually add extra zeros to my decimal in order to make this division, because the 3 repeats. This is a recurring decimal. Now the way we write that, when we write 3 and it's got a recurring decimal, we write it simply as 0.3, and we put a dot over the top of the 3 in order to show that that recurs, that it repeats over and over and over again. There's other type of recurring decimals as well. Sometimes we'll have a pattern that repeats within our decimal. So you can see this example of a decimal has a repeating pattern 3 4 5, 3 4 5, 3 4 5, 3 4 5. And rather than having to write this long string and continuing on forever and ever, the way that we can write this recurring decimal is simply by paying 0.345, and then we use 2 dots, 1 over the first digit of the recurring decimal and 1 over the last digit of the recurring part of the decimal. And this indicates to mathematicians that the decimal is actually 3 4 5, 3 4 5, and so on. Sometimes you might also have a recurring decimal following a digit. So you can see here our 0.266666 and so on, we have a recurring 6. In this case what we do is we'd once again use a single dot, but we'd put the non-recurring part of the decimal, so 0.2, then we'd write our digit 6 and we'd just put a single dot over the 6 to show that that 6 repeats. I hope this was a useful introduction to terminating and recurring decimals.